This is Imran Ali and I'm here to tell you about physical modeling in MATLAB using Simscape and Simscape Multibody. So, what exactly is a Simscape? Right? Simscape is a toolbox from MATLAB which enables you to do physical modeling, right? It helps you to create the models of physical systems within the Simulink environment in MATLAB. So Simscape is the product that is actually in the MATLAB Simulink, in the platform of Simulink, and it allows you to do the models of physically for your system, means the mechanical or the electrical system, power electronic systems, the hydraulic system, and so on. So you can leverage the Simulink Simscape modeling for multi-domain systems. And on the top of the Simscape you have a lot of add-on products as well. So there is a basic Simscape, and then on the top of that you have electrical Simscape, the driveline Simscape, the Simscape multibody, and Simscape fluids. Okay, for each of those specific tools. So here are some of the applications of Simscape, and one of the examples of the Simscape applications is called the hybrid electric vehicle, which is a very hot topic nowadays. So how you can use Simscape for these electrical vehicles? So basically you can model the whole powertrain system that contains the electric motors, the generator, batteries, and the combustion engines. You can also design the control system for your model within Simscape. Here is another example of backhoe with the multiple hydraulic cylinders, which has been developed in Simscape. It's a completely different example which focuses on the hydraulic domain. It has the mechanical and hydraulic parts. So you can model the pumps and the valves, the control actuators, and control system to track the reference positions, right? So basically Simscale has foundation blocks for more than 10 different physical domains, which includes the mechanical, electrical, hydraulic, and so on. And also you can create your custom components with the Simscape language, right? And in addition to pre-built blocks which are there in Simscape, you can even create your own blocks by coding in the MATLAB environment, the Simscape language. So you have to write the code for the blocks. So basically this is a solver technology for the systems of the differential and the algebraic equations, right? And all the add-on products which I mentioned, like Simscape multibody, electrical, and so on, they comes with the Simscape, so you don't have to purchase additionally or separately. And also Simscape has support for the C code generation, meaning that once you have your model in Simscape, right, then you can automatically generate the C code out of it, which you can deploy to your any hardwares. So you can test your algorithms directly on any embedded microcontrollers or some other hardwares directly from Simscape. So Simscape has component models, mean in physical domains, and you don't need to know the equations of these blocks. For example, if you have any system like this, these gearbox, the fillet chamber, all of that. So already these are pre-built blocks, so you don't have to know the underlying mathematical equations of your models. You just need to know the physical circuit or how physically it is connected, and then since those blocks are already there, the physical block as such, so you just have to connect it. But in Simulink, that's the difference. In Simulink, you model your system based on the mathematical equations. So if you have a system that is on differential equation, right, so in Simulink you would use those equation in modeling, but in Simscape all those blocks would be the physical blocks, which you can directly use. So it's a lot more easier than Simulink. Also, another good thing about Simscape is that you can import your CAD models into Simscape platform. So for example, if you CAD is a very popular used tool for mechanical system designs. So if you have already created a mechanical design of your model in CAD, then you can import those models into Simscape and automatically convert those CAD blocks into a Simscape equivalent box. So that's also another advantage for your design. You can use other tools like AutoCAD, SolidWorks, and then if you want to add more features to your blocks, or for example if you want to add your some kind of an actuator or control system to your mechanism, then that's where Simscape has a lot of advantage. So you can bring in those CAD blocks into Simscape and add those additional features around it. uh, So basically the underlying Simscape solver is going to solve all the equations of your model, so you don't have to worry about it. It has the underlying system, the solver technology for solving all these different types of equations. And also the Simscape offers very good logging and visualization tools, so you can see animations like this. You can even see the 3D animations of your mechanical systems. And as I said, it supports the C code generation. So even if you want to deploy your algorithm to a hardware, you can do that directly from Simscape, right? So there's the embedded coder toolbox using which you can generate the C code out of it and then deploy it to your different types of hardwares, right? So you can test your controller or whatever algorithms directly on your hardwares, so that really saves the cost, and before you actually build the physical system you can prototype your algorithm on hardwares. So these Simscape models can be shared in different formats. You can share it as a Simscape model, or you can create the user interface or apps out of it and then share it to someone else. And even model protection is also allowed in Simscape, so you can also create read-only password protected versions of your model and then share it to someone else. So if I take each domain, just to show you some of the examples from each domain. So if you were to model a mechanical system, for example if you have a mass spring damper, a very basic mechanical system, so in Simscape you already have the mass block, the spring block, and all of this, the inertia and so on. So you just need to connect it and then you can simulate it. So it's as easy, very easy. So this is shown here is a double mass spring damper model. So if you were to model this in Simulink, then you need to know the underlying differential equation of the mass spring damper and then you can simulate. But for very complex system like it's not practical to drive the equation of your system. For example, if you have like a vehicle, or for example the nuclear power plant and so on, so it's not at all practical to drive the certain equation. So that's where the Simscape really helps you to do the physical modeling, where you have the physical blocks which you can directly use. And you can also combine Simscape with other advanced toolboxes like Simscape Driveline and Simscape Multibody to model the more complex system. So you can find all the basic foundation blocks in Simscape, but if you want to make use of advanced blocks like for example, if in a vehicle you have different parts like a gear, the brakes, the wheels and so on, so in that case you have to use the Simscape Driveline or the Simscape Multibody. So this is an example of a slider crank mechanism, and you have directly the block for slider crank, as you can see this. So using this you don't have to know the underlying equation, you can directly use it and change the parameter like the crank radius, the length, the inertia and so on. So you can just use these blocks directly and change the value accordingly. And for some blocks you can also inspect the source code, as in the block you can see the source code. So yes, this is the source code. So just click on it and you can see how that block works, what is the underlying equation, what is the mechanism. It's not there for all, but for someone you can find it there. And now for modeling electrical systems, again there is a foundation library where you can find basic electrical elements like the resistor, the diodes, the bonds and so on. And also you can combine already existing blocks to create custom blocks, right? So, and you can simulate this model and see the result output response. So this one also you can combine with Simscape electrical to model more complex. And then there's a library for isothermal liquids. So it offers libraries for fluid systems when you want to model hydraulic models, you can make use of this. But isothermal liquid domain is especially for systems that where temperature does not affect the fluid properties. So you can find all those different blocks. And there's a specific library for hydraulic systems itself. So there you can find the orifices and pistons and the variable volume chamber and so on. And there's an advanced toolbox for this also which you can use. So you can combine the blocks from Simscape tools also in conjunction with blocks from the Simscape hydraulics to model more complex system. And then there's a gas library where you can find all the blocks for pneumatic elements, which deals with gas in specific. So you can simulate the gas properties like specific heat or viscosity, and you can simulate the pressure and thermal effects. And for pneumatic applications, again, there are blocks, right, so which can be used for modeling the robotic arms or the basic gas actuators, the valves, and so on. Then there's another thermal library where you can find the basic thermal elements like the blocks that can be used for conductive, convective, and radiative heat transfer, and also model thermal effects in solids and non-flowing fluid systems. And also for any of these system you can also design the controllers for it, right? And then if you want to model a heat exchanger, okay, so heat exchanger is a device which transfers the heat from one fluid to another fluid. So it's used in a lot of applications like air conditioning or refrigerations, chemical plants, and so on. So if you want to model that kind of heat transfer or applications, you can make use of it. It's also from the thermal library. And then there's another library for modeling magnetic systems. So this has foundation libraries for basic magnetic elements like electromagnetic converter, the magnetic reference, and so on. So the physical system you can add magnetic effects. Then there's so you can see there are so many of these, so close to 10 foundation libraries itself. In addition we have advanced libraries as well. So there's another specifically for thermal liquid systems, uh, where you can find these different common blocks which you can use to model thermal liquid systems. And recently there's a new library also which called it moist air domain and library. So that's specifically for modeling the flow of the mixture of gases, the mixture of moist air, water vapor, and trace gas. So it's a combination which is widely used in applications like HVAC and the environmental control system and so on. And for each of these domains, uh, you can see that if you look closely you can see the color coding also. So for example, for mechanical systems, all the blocks will be green colored, or the connection is with the green color. So for electrical domains all the blocks are in blue in color, and so on. So you can instantly identify by looking the color and the line styles. And as I said, you can also model custom components, meaning you can create your own blocks. So from already existing foundation library blocks you can combine some of them with other blocks from other libraries and create a new one. So in that case you have to write the code for it, right? So as you can see, this is a code as an example how you can add a component called the lossy ultra capacitor is an example. So this is not an already existing block in Simscape, but if you want to create such a block you can do that from the existing blocks. So for that you have to follow a certain syntax. It's based on MATLAB itself, but you can find it in the documentation what is the correct syntax for the Simscape. So you need to define the component with the component, the name of block, and then you need to define the nodes, like what is the positive and negative terminal of it, and then the parameters, the constants in the variables, both parameters, and like the variables can be capacitor, voltage, and so on. So like this, and you also need to define the equations. What are the, so these are the underlying equations of your model or the block. So once you have done that, you have created a block. Like as an example, this is the lossy ultra capacitor. When you open that, you can change the parameters for that block. Right, and even you, if there's an already existing block, you can also define physical network ports for your block, like which is positive and negative. So this is what you define in nodes. The in codes, when you define nodes, you define the positive negative terminals. So if you were to compare between the signal based modeling methods and the physical modeling, the system modeling methods, so Simulink is an example of signal based modeling. As I said, you need to know the equations for it, and it's flexible, but difficulty is you need to know the domains very clearly. You need to have the expertise in certain areas including mathematics and physics, and you need to derive the equations, so that could also lead to some errors while deriving the equations, so that's also difficult. And then the resulting model can be difficult to read and maintain. So Simulink models for vehicle transmission system might look something like this, but in certain each of these block, like the engine, clutch, and so on, you have so many hundreds of Simulink blocks which are modeled based on the equations of engine, clutch, and so on. But with physical modeling, you don't need to system level equation not need to be derived, because they are already have the system level equation derived within the blocks. You just need to use them and connect them physically, so the model is easier to read and you understand the structure of this by looking at the model, and the new technologies or designs can be easily incorporated into the model. So now let's see an example of how basic Simscape can be used for modeling a DC motor. So DC motor is a machine to convert electrical energy into mechanical. So you provide an input voltage to it, and then voltage is converted to an equivalent torque, which is then used to move something or rotate something and so on. So you're converting electricity into mechanical motion. So if you look at, if you were to drive this DC motor equation and model it in Simulink, it will look like this, right? So you can see an integrator blocks and so on. So it's totally based on the equation. So if you look at the equation of the DC motor, so there are two equations, one for electrical di by dt and so on, and the other equation is for the mechanical output side. So that is the d omega by dt. So omega is for the angular velocity and equals to this, so on. So it's based on this differential equation that you model it in Simulink. So you then use integrators to integrate these differential equations. While if you were to model this in Simscape, it will look like this. Okay, so where you can see it's not based on the differential equation of your system, but it's based on the physical connections or the physical electrical circuits and the physical how the mechanical parts are connected. So on the electrical side of the DC motor is basically an RL circuit, right? So you can see there's a voltage source, and that voltage is then given to a circuit with of resistors and the inductors, and these both these systems, you can see the color difference as well. So the blue circuit, or all the blue blocks, they are the electrical domain blocks, and all the green blocks, they are the mechanical domain blocks. So you can see the connecting blocks is used to connect both the blocks. So whenever you connect two different domains, you need to always use the converters. So in this case there is an rotational electromechanical converter. This is how it looks like when you model a DC motor in Simscape. While for having the hands-on experiment or actually modeling it in MATLAB, or how I model this DC motor, connect the different physical components and so on, you need to search for the part 2 of this video.